Hello everyone, welcome back to our network security course. Today we continue with distributed service attacks and denial of service attacks and distributed denial of service attacks. So let's start with a simple picture. And we first consider victims of the denial of service attack. So actually there is a primary victim, that is actually the victim that the attacker is attacking. So the attacker here attacks the services, processes or users that directly inside this victim's service, let's say. So this is the primary victim. But today probably most of you know that generally the attack doesn't come from the attacker, but instead the attacker has some masters. Then these masters infected some computers, which are called slaves, and sometimes they are called zombies. And these actually these devices don't know that their system are infected. So these bots or zombies actually perform the attack to the victim. So they are in this case the secondary victims. So this is important because years ago the viruses that we have actually was attacking a computer or service, so it was to cause some damage. But nowadays hackers are comparing number of computers they are infected, so they are trying to create botnets which are larger and larger, and they actually try to sell these botnets to other people. And most of the time this slaves doesn't know that their systems are infected, and this is actually a huge problem. So this is how a botnet works. The attacker initiates the attack, the control service actually commands the botnet, and botnet sends the traffic to the victim, and this way performs a denial of service attack. So there are many different types of attacks and there are many names, so it is a good idea to classify them, and Certified Ethical Hacking version 10 actually performs some classification. In this talk I will briefly mention all of these attacks, maybe in one or two sentences. Some of them we already talked about before, but there are many attack types, so it is a good idea to categorize them, and here they categorize it like volumetric attacks, protocol attacks, and application layer attacks. So let's start with volumetric attacks. These are also known as bandwidth depleting attacks. So they are measured in bits per second, because you're actually since you're attacking the bandwidth, the higher the attack is better in terms of bits per second. The target is stateless protocols that have no built-in congestion avoidance. Method is flood a victim with network traffic. There are two types, flood attack and amplification attack. In the flood attack, zombies send traffic to consume victims' bandwidth. In the amplification attacks, bots send messages to broadcast IPs, so amplification of malicious traffic. So there are many attack types. The techniques, some of them are called UDP Flood Attack, ICMP Flood Attack, Ping of Dead Attack, Smurf Attack, Malformed IP Packet Flood Attack, and Spoofed IP Packet Flood Attack. So let's talk about them. I will actually briefly mention a few of them in the following slides. In the protocol attacks, these are measured in packets or connections per second. Target is usually connection state tables in network devices. Method is to consume state table resource to prevent further connections. The protocol attack techniques include like SYN flood attack, ACK flood attack, TCP connection flood attack, TCP state exhaustion attack, fragmentation attack, and RST attack. Application layer attacks, they are also known as application level flood attacks. These are measured in requests per second. Target is vulnerabilities in applications, for example buffer overflows or application layer protocols. Method is to keep connections open to prevent further connections. And here a few application layer attack techniques, HTTP flood attack and slow loris attack, which actually we already talked about in the application layer security. So let's briefly mention some of the denial of service attacks and distributed denial of service attack techniques. Let's start with the ICMP attack. ICMP is actually a protocol, the Internet Control Message Protocol. It is a supporting protocol in the Internet Protocol suite. It is used by network devices, not our computers. It is for sending error messages and operational information, for example, messages on service availability. ICMP is different than transport protocols such as TCP and UDP. ICMP is not typically used to exchange data between systems, nor is it regularly employed by end-user network applications, with the exception of some diagnostic tools like ping and traceroute. A transport layer attack. So let's start with the UDP Flood Attack for the ICMP. This is a transport layer attack. The attacker sends spoofed UDP packets at a high rate to the target. Packets are sent to random ports. The server checks non-existent applications in the ports and replies by an ICMP packet destination unreachable. So this is a network resource consumption attack. How do we mitigate it? The easiest way is to limit the response rate of ICMP packets. So the attacker commands the bot to send spoofed UDP packets, so the target actually sends them but receives ICMP error packages of destination unreachable. ICMP flood attack is similar. In this case, the attacker sends ICMP echo request packets to the target. The target replies by sending response packets. In case of no threshold limit on the target, the network is saturated after a while. So to mitigate, you have to have a threshold actually. Ping of that and Smurf attack. Ping of that is the attack where the attacker sends malformed packets by ping, for example, oversized packets. Malformed packets may cause the target system to crash. Smurf attack. ICMP packets, a fake echo request containing a spoof source IP, are broadcast to a computer network using an IP broadcast address. So, of course, I'm briefly mentioning all of these attacks, but as you can see, most of the time, in order to mitigate these attacks, you can mitigate most of them if the settings of your network is correct. So if network administrations design the systems in a good way, for instance, in this case, when you receive an oversized packet, if your system is correctly configured, then they will directly drop. There wouldn't be any problem. But if the system is not, if the settings are not correct, then malformed packets may cause systems to crash. And in this case here, most of the time, the spoof IPs cause a problem in most of the attacks. The problem is that you can send a packet and for the source IP you can write a fake IP there, right? But most of the time, even people are performing attacks where even the packet comes from a country as a source IP, they write an IP of a different country. So this can actually be prevented if the ISPs are configured correctly. So most of the time, correct configuration actually prevents most of the denial of service attacks. So let's continue with SYN flood attack. This is an exploitation of three-way handshake. The attacker sends a TCP SYN request to the target. The target sends back a SYN ACK message. The attacker does not send ACK message back, so the connection now is open. Instead, the target starts waiting for a connection during a predefined timeout period in a listen queue, for example 75 seconds. But then the attacker keeps sending SYN packets but not send back any ACK messages. So this way, when a regular user tries to connect the system, since the system is busy, the service will be unreachable. A quick solution is stop packet retransmission. IP fragmentation attack is also another attack where it is the datagram fragmentation mechanism is exploited. The concept of IP fragmentation is as follows: fragmenting IP datagrams into small packets and reassembling the packets into the original IP datagram. So this is actually the mechanism behind it. You cannot just send an IP datagram of any size because there is a maximum transfer unit size, and for a network this is generally 1500 bytes. So you cannot send 5 megabytes of a datagram as a single packet. You have to fragment it. But how you fragment it actually depends on your choice. You can use this maximum transfer unit size. So for example, if you want to send 4 kilobytes of 4,000 bytes, let's say, and since the maximum threshold is 1500, you can divide it into 3 fragments, like the maximum size here, and the remaining in the third one. So you can send it like this. But you can also fragment into like 4,000 fragments where each of them contains a single byte, and this way you can perform an attack actually. So this is how the fragmentation and reassembly actually occurs. So let's move on to the IP fragmentation attack. This is the mechanism behind it. Packets usually uninspected by IDS or IPS, which is intrusion detection systems or intrusion prevention systems, which we'll be talking in the next video actually. So let's look at UDP ICMP fragmentation attacks. Is face packets larger than the MTU size. Again, if the system is not configured correctly, this will cause a problem, and it will be impossible to reassemble the packets because they are larger than the threshold. But this way target resources are consumed. TCP fragmentation attacks, they're also known as teardrop. They prevent reassembling of data packets. So there are many other types of denial of service attacks. Multi-vector attacks, which is a combination of denial of service and distributed denial of service attacks. PDoS, permanent denial of service attacks, also known as flashing. These target the hardware, for example printers or networking devices, and try to cause a permanent damage. These are usually due to a file pretending as a firmware update. Distributed reflection denial of service attacks, or also known as spoofed attack, an exploitation of the three-way handshake. The attacker sends numerous requests with the spoofed source IP address, the victim. The requests are sent to the intermediate nodes. These are called reflectors. Reflectors reply with numerous responses to the spoofed IP. The victim is flooded. Of course, routers and many middle machines during the communication has blacklists. So when a denial of service attack occurs, a lot of IPs are put in the blacklist, this way to overcome the attack. But if the botnet is really huge, or if they are using spoofed IPs, then these won't solve the problem. Here is a picture for the DDoS attack. So what are the challenges in the denial of service attack preventions? This is actually a hot topic. Actually, this has been a hot topic for the last 10 years. The major goal is to distinguish between benign packets and anomalous packets. Technical challenge: high traffic volume, impossible to scan each and every packet. So it is very hard to do it in real time. The common method: statistical machine learning techniques for anomaly detection. Academic challenge is the obtaining real data and running simulations. Here, but one thing to mention, but I will most probably mention it when we will be talking about intrusion detection systems. There are many papers, academic papers, many projects, many software solutions and so on, saying that they are using machine learning techniques for anomaly detection. But once you are inside the system, you will realize that these techniques to detect anomaly is not practical in real life, because there will be enormous number of false alarms. So if you have a machine learning technique or software to detect anomalies, you will have a lot of false alarms. So it doesn't matter how many employees you have, it will be very hard to check all of these alarms one by one. So Machine learning techniques for anomaly detection alone would not solve anything, but it is a good idea to always mix it with rule-based filters, and this way it becomes manageable. So data sources and methodology also challenges. Activity levels of network flow, average packet rate, randomness means high entropy, the investigation of consecutive matching packets, detection of changes in traffic flow rate in time, and so on. These are the methodologies that are used. But again, these systems may think many behavior as anomalies because people don't act in the same way always. So it is not easy to detect, again, the anomalies by machine learning techniques alone. This is why this is still a hot topic and many things need to be done here.